Okay. I wanted to go back to basically to the white paper and reflect on some of the questions in there to see how they might help us answer some of the main charge questions. And let's see, is it F4?
F5.
F5.
Might have to hit escape first.
Okay. Okay, enough of that. I wanted to talk a little bit about trace element analysis. Neil, you're going to think I'm picking on you, but Neil had a very nice table in his in the white paper talking about XRF elements that are analyzed in either or both of the CSN and improved networks. And I got to thinking about that and looking at the list and decided to put my own personal ranking on those elements in terms of what I would do with those if somebody presented me with a data set. So I came up with 3 rankings. They're my personal rankings. That's why I call this one perspective. I don't expect it to be universally applicable, and I don't expect it to be universally believed. But I think almost anybody could come up with a similar ranking. And so what we have is out of 33 elements, I'll just cut to the chase. On the bottom, there are about 12 of them that I would use pretty freely without too much worry about what their data quality is, because there are pretty well-known ways of analyzing these elements and good standards for doing it. There are another 3 or 4 that I would proceed cautiously with for any number of reasons. And then there are about 18, a little bit more than half, that I would proceed only with extreme caution or even not proceed at all. Some of those elements over on the right-hand corner, I put in the ratios of crustal element to aluminum, or the element in the Earth's crust to aluminum, just as kind of a reference. An interesting one might be silver. It's sort of like the platinum group elements in that you can't even measure it with ICP-MS unless you pre-concentrate the sample. But it's on the list. And what I would submit to you is if you find samples that have detectable silver in them, what you need to do is go find the source, put a high vol there next to the source, and instead of sending the filters to the laboratory, send them to the bank. Get them into your safe deposit box, because that, if you can detect silver in the atmosphere, you're very close to a major source, maybe the only one. So anyhow, I just want to say that I think to the extent that metals are important, I'm not saying they are, but if they are important from a health standpoint, the data we have are limited. Now, maybe there's a bright spot to this. In the white paper, Neil said semi-continuous elemental analyzers have been deployed at a couple of sites. And the reason they've only gone to a couple of sites is because they're expensive. They're $125K a shot. And if you're building a site, you need to make some compromises. So $125K is a great big compromise. On the other hand, $125K is not a lot of money for an analytical laboratory whose job is to measure metals on filters. And so the question that I want to pose is, can we take that sensitivity that is now going on in the field, we'll take it at face value that it actually works. Can we take that, put it into a laboratory? If we can get that in a laboratory, then we can get a lot of trace elements. Okay. There's some magic involved, I'm sure, but that's a question I want to pose to folks. In terms of speciation measurements, do we have the correct list? Well, I think we have the correct list in terms of trace elements. We don't have the correct analytical technique. Okay, but we're not measuring water-soluble trace elements and a few other things that have come up recently in certain health associations, so we may want to think about that. We're talking mainly about particles here, but I want to get us to think about gases. Ammonia, or at least NHX, is important to measure. We need to understand, although it may not be a regulated quantity, we need to understand how that's involved in the PM 2.5 process. And then a secondary question, do we need to speciate organic carbon? That's a toughie. I think everybody would like to do it, but it's expensive. I would submit there are some, Judy Chow has some thermal desorption data sets that should be very carefully analyzed for their value to see what you would want to analyze going forward. and whether you need the group elements or compounds, et cetera, to make them useful for health outcome work. Am I running out of time here? Okay. Need for enhanced monitoring? Certainly. I think everybody's got their wish list, but I think going back to for the NCORE sites, I think I would certainly add photolytic or cavity ring down NO2, which is going to give you very good measurements of NO2. That will also flange up nicely with your near road sites. Also continuous ammonia or NHX. NHX is pretty easy to measure continuously, actually, easier than ammonia. And maybe some fractionation of PM 2.5. Michael mentioned PM 0.1. Maybe something as simple as PM 1, which gets rid of most of the crustals, not all of them, but most of them. Use of archived FRM filters. This is a gold mine. This is a gold mine because we have tens of thousands of filters out there. They've been stored in various ways, so they're not useful for everything, but they can help us design the prospective studies. What are the elements we need, and how do we analyze them, and how often are they above the detection limit? We've got the samples to answer those questions. We just need to come up with some pilot studies or some well-designed experiments to do that. We would, as Neil mentioned, non-destructive analyses are preferred to the extent that they are sensitive enough and give us the numbers that we need. They're good because you don't have to sacrifice a filter. And then finally, my mundane proposal for the day is I would like to see EPA come up with an RFP for a methodology to produce contamination-free filter sections. As anybody who's dealt with FRM filters know, and that's what this archive is made out of, FRM filters are very difficult to subdivide. And if we could come up with a contamination-free method for having or quartering or punching these filters, then we can do something like experiments on these filters without sacrificing the whole thing. Right now, you basically sacrifice the whole thing, and that piece of history is gone. Frequency of sampling, I think continuous analyzers are great, and we need as many as we can, and the network is pretty depauperate in those measurements right now. I think they can help us understand intersite variability just by looking at the effect of wind direction on concentrations. It's going to give us a lot of information about siting and variability within studies or within cities and whether we need additional sites or not. I'm not convinced we do, but by analyzing the continuous data, we can get some sense of whether we do. 1 and 3 day sampling, which is the bulk of what we have, I think that's fine for pattern and trend analysis. It's probably okay for some level of model evaluation. And for health outcome studies, I'd actually throw the question back to the group. I think there are really two related questions: is how does that affect your statistical power, and how soon do you need an answer? If you need an answer in 2017, then 1 and 3 day sampling is probably fine. But if you need an answer in 2012 to guide what's going to happen between now and 2017, then you're going to need a lot more data density, I would suspect.